In this tutorial, we're going to look at initial conditions. Suppose a general differential equation is given as y of x equals alpha e exponent negative x plus beta e exponent 3x of the differential equation d squared y on dx squared minus 2 dy on dx minus 3y. That's y prime prime minus 2y prime minus 3y equals to 0. Now we want to determine the particular solution with an initial conditions as y of 0 equals 3 and y prime of 0 equals 4. So the next thing here, the first thing to do here is to write our general solution, our general function. The function y equals alpha e exponent negative x plus beta e exponent 3x. Now, getting this one down, we need to find our y prime and y prime prime. But before that, given the initial condition, y of 0 equals 3, we can then substitute these initial conditions into our first function to find for our first equation. So when we substitute the initial condition here into the function, we are going to have y is 3 and x is 0. So e exponent negative 0 plus beta e exponent 3 times 0. So this gives us alpha times 1 plus beta times 1. And this is equal to 3 alpha plus beta. Now let's call this one as equation 1. So the next thing is to find for the particular solution with the initial condition y prime of 0 equals 4. But before that, we need to get our y prime from the function. So from the function y equals alpha e exponent negative x plus beta e exponent 3x, we can find our y prime, that's the first derivative of y, as. So we differentiate this one. We are going to have negative alpha e exponent negative x plus, then we differentiate this one to, we're going to have 3 beta e exponent 3x. Now let's substitute the initial conditions in. So we're going to have 4 equals negative alpha e exponent 0 plus 3 beta e exponent 3 times 0. So we are going to have 4 equals negative e times 1 plus 3 beta times 1. And that gives us 4 equals negative alpha plus 3 beta. Now let's call this one as equation 2. So here we need to find the value for alpha and beta. And for that matter, we need to solve these two equations simultaneously. Now from equation 1, we can make alpha the subject. So let alpha be equal to 3 minus beta. Now substitute alpha equals 3 minus beta into equation 2. And we're going to have 4 equals, now alpha is 3 minus beta. So negative into brackets, 3 minus beta plus 3 beta. Now let's expand what is in the brackets here. So you're going to have 4 equals negative 3 plus negative times negative beta will give positive beta plus 3b. Now 4, we bring the negative 3 here, so plus 3 equals 4 beta. So 7 equals 4 beta. Now divide here by 4. Divide here too by 4. Now beta equals 7 on 4. So if the value of beta is equal to 7 on 4, can now substitute it here to find for the value of alpha. So alpha equals 3 minus 7 on 4, and that gives us 5 on 4. So alpha equals to 5 on 4. So getting the values for alpha and beta down, can now substitute them back into the actual function given. So the function given was this one. So this is the function given. So we are going to substitute the value of alpha and beta here respectively. So the final result is going to be alpha is 5 on 4 e exponent negative x, and then beta is 7 on 4 e exponent 3x. So this is how to find for the particular solution of a differential equation given the initial conditions. Thank you, and don't forget to subscribe to our channel.